So good morning. I presented something yesterday, and there were lots of questions from some of you about the leadership aspects. So I want to dig a little bit deeper is how can we characterize if a country or an institute is a leader. And on Monday I met also with the chief scientist of Australia, and we talked about many things, but somehow that's also resonated very closely with him. So some data, this comes from Scopus. And I want to start with a comparison of the top 20 countries. So what you see here in the histograms is article output, and not surprisingly, the US is an absolute leader. Number 2 is China, with half of that. 5 years ago, China was number 5. And so here you see Australia doing pretty well for its population. Not the size, but population. And on the red, you see here the growth of articles, and it gives a completely different pattern. But I think we missed the US, by the way. So we start here that China is growing with a whopping more than 22%. Somehow we think the US is not growing. Then the other growth nations are India, which I also mentioned yesterday, Brazil, Turkey. So very interesting. And then there are some countries that are not growing so fast. So, the UK is doing all right, Germany okay, Japan certainly not growing fast. And I think Australia is doing pretty good. So it's not the same league as India or China, but it's certainly much growing faster than the world's average. So another criteria is citations per article, a kind of proxy for quality. And here we see that if you're in a smaller European nation, whether it's my country or Switzerland or Sweden, you do pretty well. And then there are the big powerhouses, the US and the UK and Germany. And Australia is more or less in that league. And then it drops rapidly after Australia. And then you see on the right-hand side, we have countries like China, Russia, Turkey. So very productive, growing rapidly. But the quality still is low. Another criteria which we have, we call it state of the art, and this is something where we measure how recent the references are in the publications from these countries. So it's an indication how up to date you are. And it's a relative scale. 0 is the average. And if you're very up to date, you have a very positive state of the art. If you're a little bit, if all your citations are to articles in the 50s, then you have a very negative state of the art. And here we see a very interesting pattern. So Switzerland, which was, the country leading in quality, is also number 1 in up-to-dateness. The Netherlands again, Germany, Belgium, Italy. So it seems like there's a kind of correlation between quality and up-to-dateness. And you see here at the bottom, Russia, India, Turkey, Brazil. However, there's one exception to this rule, and it is in China. So in China, they publish a lot, they grow really fast, and they know how to cite the most recent stuff. So and they don't follow this correlation, while the quality is still low. Australia is doing all right, so a little bit above average. So you're doing okay for up-to-dateness, so to say. I also, you won't be able to see this, but the next question, and you get the slides, so you can look at your own institute. So who contributes to this strength in Australia? And so I ranked here all the institutes based on article output. And you will not be surprised. The University of Sydney is number 1, then Melbourne, then Queensland. We have here also the growth. And you see some institutes growing really fast. And here is CPA, citations per article. And you see there are some institutes who do better than others. This is not, by the way, corrected for different citation patterns in different disciplines. So if you compare an institute of technology, where there are not so many citations, with a medical school, then of course the medical school will always do better. But for whole universities, this is very valuable. And I think almost all universities here have a medical school. So, and also here you see the citations per, the state of the art. And of course, here it's normalized for all the institutes in Australia. So, I presented this map of science, and there were some questions about this. So I will go one step back. How do we produce such a map? So what we take 5 years of Scopus data. then we look at the highly cited references in there. Then we do a very detailed co-citations analysis. And we generate 100,000 specialized areas. So I cannot stress, these are not big fields like physics, but this is like a very specialized area. And then we're looking in those areas, who are the leaders? And leadership is defined by number of articles or number of citations or the state of the art, so how up to date you are. And so then we do this exercise on a country level, so how is this country compared to other countries, or at an institutional level, how does this institute compare to other institutes? So here you see here all the different clusters, and then we look, so where are the leaders in there, and we produce this kind of map. Now for Australia, you get a map like this, so every circle you see here is a competency, a specialized area where Australia is outperforming other countries, according to these 3 leadership criteria. You see here the different subject matters, physics, chemistry, engineering, earth sciences, etc. And you see lots of these circles also in the center. These are the multidisciplinary circles. So this methodology works really, really well to identify multidisciplinary, interdisciplinary areas. So for Australia, it's very interesting if you look at the map, because there are 2 kind of areas where Australia is really stronger, and the other areas are relatively sparse. And so the first one here, and that's all in the area of biology, earth sciences and biotechnology, but especially biology. And I think agriculture is also captured in Scopus under biology here. We don't have a separate, so it could be that it's very much into agriculture, although I'm not sure, but it's my gut feeling. And another area is in the health. So it's not so much medical, but it's very much in the health area. And so that's where Australia really jumps out. Now look at some other countries. So actually the map for the US is kind of boring because of its size. It's very easy to be a leader almost in everything, and they are. But then their strongest leadership is still here in the life sciences and the medical sciences. Quite a contrast with China. So China does really well with this methodology because, one, they publish a lot and they're very up-to-date. And so we see that the Chinese are more in the traditional fields, in computer science, in chemistry, in physics, in engineering, and they're relatively weak in the medical field. UK, very good in the social sciences, also in the medical field. And then in Japan, you see also a bit of a mix of the 2, but very weak, for instance, in the social sciences. Okay, then we're going to get a breakdown, and this is for Australia. What you see here on the outer ring is all the different subject areas where Australia is publishing. And on the inner ring is all the articles within these bubbles, with the leadership articles. And so I just want to kind of, there are a few things that jump out. So for instance, in the health sciences, 11% is published overall. But then if you look at the leadership articles, it's much more. So Australia does very well in the health sciences, as I said earlier. You don't see that, for instance, in computer science. So a big chunk of the overall articles are in computer science. If you look at the leadership articles, it's much smaller. So somehow it doesn't translate to a leadership role in computer science. And we can do the same exercise for other countries, but I won't go into much detail. It's also in your pack if you're interested. Now, another aspect is collaboration. And I just took one example to kind of show what we can do nowadays in the area of collaboration. I took the Bio 21 cluster. Must be very well known to you here. So for that cluster, we have 46,000 articles in Spotlight. In Spotlight, that comes from Scopus. And of those, there are 17,000 leadership articles. And they produce together more than 300 competencies of those circles. Now, you will not be surprised, they're very active in the medical field, health sciences and biology. And then in the dark area are the leadership articles. So they do very well. If you see that almost half of their articles they publish are in biology, for instance, are leadership articles. That's really a good achievement. In computer science, they also publish quite a lot, but relatively fewer leadership articles, which you would kind of expect maybe for a group like the Bio 21. We can then map all the institutes they collaborate with. So here is an example for Australia. We know that they collaborate with 77 institutes within Australia. And here I give an overview. So again, of course, it's the big players, University of Sydney, etc. But what I found very interesting in this list is that if you look at the first international collaborators, it's Harvard, it's Cambridge, it's the National University of Singapore, it's UCL, it's Oxford, University of Toronto. So somehow they succeeded with picking the really high-quality collaborators overseas. And I think that's quite an achievement. And we don't see that same pattern from other institutes. So I've done the exercise with, say, for instance, Waseda University in Japan, and they really go more to, I wouldn't say the second rate, but a little bit not the top institutes worldwide. So say you're interested in China, who do you collaborate with in China? We have that information. And then finally, because I think I got a little sign I shouldn't talk too much, so to conclude, so these are all the institutes which are active in the same competencies as the Bio21 cluster, but today there are no collaborations. So you see that reflected here. These are all the articles they publish in the same clusters. These are all the co-authored articles, so there are 0. And so if the Bio21 would say, well, I want to expand our collaboration partners, and they go to Italy, then the University of Palermo would be a prime candidate. So this is just based on statistics, so you must be always a little bit careful. I know, for instance, in my own country, University of Twente would be an interesting candidate. If then you say, well, we want to do this in China, then you can immediately see the China Medical University in Taichung would be the best partner for this university. So I just wanted to share this with you because I feel the metrics are a very good basis for the policy discussions we're going to have. And then I conclude with that.